Welcome back to my channel. In this video, we are still talking about the application of first order differential equation to growth or decay. And we have a decay problem here. It says that a certain radioactive material is known to decay at a rate proportional to the amount present. Then I say that if initially there is 50 milligram of the material present, and after 2 hours, it is observed that the material has lost 10% of its original mass. Then A question said, find an expression for the mass of the material remaining at any time t. And then B question said, we should find the mass of the material after 4 hours. Then C question said that we should find the time at which the material has decayed to 1/2 of its original mass. Okay, so this is a decay problem. We're going to be having that the P over the T is directly proportional to the population present. So if you remove proportionality sign, we are going to be bringing in a constant. So therefore, the P over the T is equal to what? A constant P. Or let me use R as my constant. A constant, then P. So if this is first order differential equation and it is separable. So if we separate it, I'm going to have that the P over P is equal to what? R dt. So if we integrate both sides, I'm going to be having the integral of 1 over P dP is equal to what? The integral of R dt. So if we integrate this, I'm going to having that the P is equal to what? This is RT plus a constant. So I'm going to be having that my P will now be what? Exponential of RT plus a constant. So my P becomes exponential RT multiplied by exponential C. So therefore my P will now be what? A exponential RT. So that is the formula we are going to be using. Now, normally some people will introduce negative here to show that it is your R will be negative here to show that it is decay. It's the same thing. If you put negative in here before solving, after solving, you're going to be getting R to be positive, which means if you put it back here, you will not have that here. It will not be. If you use negative here will not be minus RT. And if you solve and get your R, you will be getting a positive number, so that if you input it here with the negative here, you will still have a negative expression showing that it is a decay. But if you leave it as positive here, after solving, you will see that we are going to be getting a negative answer showing that it is decay as well. So any of the two methods will still give you the same answer. It's either you introduce negative initially to show that it is decay, or you will leave it, you will still get negative to equally show that it is decay. So they say that initially that the population is 50 here. So I'm going to be having that P initially, that is at T equal to 0. That is, we're looking for P naught. So therefore, P naught, which is 50, they say that 50, is it 50? Okay, yeah. 50 is equal to what? A exponential RT. So I'm having that this is, so our RT is 0. So 0 here. So anything raised to power 0 is 1. So I'm going to be having that my A is equal to what? P naught, which is equal to what? 50. Okay. So having this now, the expression will now be P is equal to what? 50 exponential what? RT for now. Okay. So now let us find our R. To find our R, we are told that after 2 hours, that this thing lost 10% of its initial population. So let us get what it is lost. The population here should be what? 50 that is already there initially, minus 10% of that 50. 10% of 50. Because they say that it lost 10% of the initial population. So which means the population present now will now be what? 50 minus 10% of this is 5. So we have 45 population left. Okay. So if we put it in our expression, this is our expression here. This is our expression. Let me call this expression equation 1. So if you put it in equation 1, you will see that what? 45 is equal to what? 50 exponential RT. And then my T here is 2. Because this was lost at 2 hours. Look at it, 2 hours. So we're having that what? 45 divided by 50 is equal to exponential 2R. So therefore, 45 divided by 50. 45 divided by 50. I'm having 0.9. So therefore, exponential 2R is equal to 0.9. So therefore, 2R will now be what? Lane 0.9. So therefore, my R will now be what? Lane 0.9 divided by 2. So I'm having what? So I'm taking lane 0.9 then divided by 2. So you see, I'm having that my R is in negative. So negative 0.05. Okay, that is the rate at which this increases. So if you put it in equation 1, you will see that our new equation will now be P is equal to what? 50 exponential minus 0.05 T. This is equation 2. You see, this negative here shows that it is a decay problem. Like I told you, but I didn't we introduced that our R is negative here. We are going to be getting just 0.05, which if you put it back here, we are still getting the same answer. So I told you anyways it's going to work. So you can try your own by introducing minus here and see what is going to happen. Okay, so having this now, so they say we should get an expression. So this is the expression they say we should get. This is answer A. So let's go to question number B. So question number B said we should get the mass of the material after 4 hours. So T is equal to 4. And then we have that P will now be equal to what? 50 exponential minus 0.05 multiplied by 4. Okay, so I'm having that my P will now be approximately, let's get that. So if we multiply this by 4 and then get the exponential of it, and then we multiply it by 50, we're having 40, we're having 40.5. So that is the current population. That is for question number B. Okay, now question number C says we should calculate the time that will calculate the time at which the material has decayed to 1/2 of its initial mass. So the current population here is equal to half of the initial mass. Okay, and what is the initial mass there? 50. So half of 50 is giving us what? Is 25. So half of 50 is 25. So the population here is 25. So I'm going to have 25 is equal to what? 50 exponential minus 0.05 T. And we are looking for T. So this will come down to have that 25 over 50 is equal to exponential minus 0.05 T. So therefore, 25 divided by 50 is giving us 0.5. So we will be having that exponential minus 0.05 T is equal to 0.5. So exponential moving here to become lane. So minus 0.05 T is equal to what? Lane 0.5. So if you do that, I'm going to have it that T will now be lane 0.5 divided by minus 0.05. So I'm going to be having this. So lane of my answer then divided by minus 0.05. So I'm having 13.9. So approximately 14. So this is approximately 14 milligram. So that is that. Did I put milligram in the other one? This should be milligram. Okay. So thank you very much for watching this particular video. Please. Okay, sorry, 13 hours. I'm looking for time. This is 14 hours. Or 13 point something hours. Anyone, depending on your own. My own is 13.8 hours. So let me leave it as 13.8 hours. So thank you very much for watching. Please don't forget to like this video, share to your friends, and subscribe if you are new to our channel. Okay, may the peace of the Lord be with you. See you in our next video. Bye bye.